Hello and welcome. Today, we're diving deep into a topic that it's really at the heart of building software that actually works: requirements engineering.
Okay, Alex, but let's be real for a second. In this whole move fast and break things world we live in, does this stuff still matter? Isn't all this super detailed upfront planning kind of old fashioned?
That is the million-dollar question, isn't it, Sarah? Because when you see projects just go completely off the rails, and trust me, it happens all the time, it almost always circles back to the same thing. They had a total misunderstanding of what they were supposed to be building in the first place. That move fast idea? It's not speed, it's just a shortcut straight to failure.
And you can see how all these things just kind of feed into each other. It's like a domino effect. We're asking our software to do more and more, way more complex things, constantly changing features. But a lot of teams just jump right in without any kind of professional process. And what happens? You get software that costs way too much and is way less reliable, all because they skip that crucial groundwork.
So, this is the really critical point. We don't fix all that chaos by just throwing planning out the window. Nope. We fix it by doing the right kind of planning. It's all about creating a super clear, shared understanding of the goal before anyone writes a single line of code.
Okay, you've got my attention. So what exactly is this right kind of planning you're talking about? Well, it's a whole discipline called requirements engineering, and its entire purpose is to define the what, long before we ever get to the how.
So at its core, it's really the process of figuring out two main things. First, what services does the system need to provide? And second, what constraints does it have to operate under? And that second part, the constraints, that's so important. This isn't just some wish list of features. It's about defining the rules of the game, the budget, the timeline, the performance you absolutely have to hit.
So wait, a requirement isn't just another item on a to-do list? Oh, not even close. Think of it like a blueprint for a house. The very first requirement might be something really high level, like a 3-bedroom family home. But way later, that same blueprint is going to detail the exact thickness of the electrical wiring. Both of those are requirements. They just live at totally different levels of detail.
And that actually brings us to a really important distinction here. We've got user requirements on one hand. These are written in just plain English for the customer, describing what they'll be able to do. And then we have system requirements, which are the nitty-gritty technical specs for the developers.
Okay, I think I get it. So a user requirement is something like, I need a button to save my work. But the system requirement is the detailed document that explains exactly what happens in the database when that button is clicked.
Exactly. You hit the nail on the head. One is the what for the user, and the other is the technical how for the builder.
Okay, that makes sense. The user wants something, the developer specifies how to build it. Seems pretty straightforward. It does seem simple, right? But here's a curveball. What if the system does everything it's supposed to do, but it's painfully slow and totally insecure? That's where we get into another layer. The difference between what a system does, its functional requirements, and how well it does it, its non-functional requirements.
So, a functional requirement is a feature, like the user can search for appointments. Easy enough. But a non-functional requirement is a quality, like that search has to return results in under 1 second. These are the constraints, the speed, the reliability, the security that so often define whether a project is a success or a failure. Because, let's be honest, if your banking app has every feature you can imagine but it crashes all the time, it's basically useless.
And here is the absolute key. You can't just say a system needs to be fast or reliable. That's wishful thinking, not a requirement. You have to make these things measurable. So easy to use becomes something concrete, like a new user can be fully trained in less than 4 hours. Reliable becomes the mean time to failure is over 1,000 hours. See? This turns these vague goals into real testable targets.
Okay, I'm with you. I get the what now, all the different types of requirements, but how do you actually, do all this? What does the process even look like? That is a fantastic question, because it's not random at all. It's a very structured, repeatable engineering process. So the whole process has 4 main activities. First up is elicitation, which is basically discovering what everyone needs. Then comes specification, which is where we write all those needs down very clearly. After that, we have validation, where we go back and check with the customer to make sure we got it right. And finally, there's management, which is all about handling changes as they come up. And the really crucial thing here is that this isn't a straight line. It's more like a spiral. You keep revisiting these steps to refine your understanding.
Elicitation, that first step, is the discovery phase, and this is where the real detective work happens. A lot of the time, stakeholders don't really know what's possible, or maybe different people have conflicting needs. So we use all kinds of techniques, like interviews, user stories, even building simple prototypes just to help everyone get on the same page and visualize the goal.
So it's like part detective, part psychologist? Definitely sounds a lot harder than just sending out a survey.
That's the perfect way to describe it. It's honestly one of the most challenging and most human parts of the entire process.
And here's a perfect example of a really popular technique called a user story. It's just a great way to capture a requirement from a real user's point of view. It has 3 parts. You've got the role, as a doctor, the goal, I want to view a patient's history, and the motivation, so that I can understand their past consultations. It's so simple, but it's powerful, and it keeps the focus exactly where it should be, on the user's value.
Now, after we've done all that work and written everything down, we validate. And this step right here might be the single most cost-effective thing you can possibly do on a software project. We just go back to the stakeholders with what we've got and ask, hey, is this really what you want? Because finding a mistake on a piece of paper costs what? Next to nothing. Finding that same mistake after 6 months of coding, well, that can literally kill a project. It's all about making sure you're building the right thing before you actually build the thing.
Okay, Alex, let's bring this all the way back around. How does all of this, the user stories, the validation, everything, how does it solve that original problem of projects failing? What's the real payoff here? The payoff is actually pretty simple. It's building good software. And good software is never an accident, it is an engineered outcome.
When we say good software, we're talking about specific things, right? We mean, is it maintainable? Can it change as a business changes? Is it dependable and secure? Is it efficient with resources? And maybe most important, is it actually acceptable to the people who have to use it every day? You have to design these qualities in from the very beginning. You can't just, bolt on security or efficiency at the very end. It just doesn't work that way.
So when you look at the whole picture, this isn't about creating a bunch of useless paperwork or slowing everybody down. It's about being professional. It's the framework that lets us get away from that chaotic move fast and break things idea.
And move to a more mature build the right thing and build it well mindset.
Precisely. It's about stacking the deck in your favor and dramatically increasing the odds of success.
Okay, I have one last question for you, Alex. If a requirement is the blueprint, we all know what happens in the real world. The client shows up halfway through building the house and says, you know what? I think I want to move the kitchen over there. What happens then? That is an absolutely fantastic question, Sarah, and honestly, that is the core challenge of pretty much all modern software development. Learning how to manage that change is what separates the good teams from the truly great ones. But that is a topic for our next explainer.